My name is Dean Peterson. I'm an Associate Principal Specialist Solutions Architect at Red Hat. I've been at Red Hat for over 5 years now, but I've spent a lot of years in the industry as an application architect. And just a little blurb about myself here. And this is my passion. Obviously, with all the AI stuff, everybody is kind of excited about this, and I'm one of those people that's probably the most excited. And when I've been going around and talking to people and seeing what other people are doing, one of the questions that comes up a lot, and I've given high level talks and kind of had high level talks, and low level talks, but a lot of times people are kind of wondering, what is it that makes Red Hat stand out? It's like, what makes it so? Why would we want to actually use RHEL AI or OpenShift AI? So that's really what this talk is. It's actually giving you a demonstration and walking through when we're trying to build something that does stuff like RAG. Like, how many people in this room? I think when Keith was talking, he asked how many people know what retrieval augmented generation is, and he explained it. But now, raise your hand if you now know what retrieval augmented generation is. Okay, so that's gonna be rough. So sometimes I talk to people and like they've heard it 30 times now, right? This is something that's in the industry and people are talking about it all the time, but it depends on the group. So I don't know I don't want to spend a lot of time rehashing like some of the stuff that he already went through. He did a good kind of a good analogy of what it is. It's like a coordinate system. So when you store data now, when you had databases in the past, like Elasticsearch, it had all these different ways that you could do fuzzy logic searching and retrieve some stuff based on different search algorithms. You can think of it kind of like that, only it's search for machines, and it uses a coordinate system. So you turn this stuff into floating point numbers, store it into a vector database, and it's like a supercharged search capability where you can actually find a whole bunch of exactly what you want from unstructured data. You just throw it in, and then the machine uses this coordinate system to find what you want. So you can get a lot of miles out of just finding the right context to give to a model. So how many people have used ChatGPT right now? Like, how many use it on a daily basis? And how many of you, when you use it, have to copy and paste some stuff before you ask it a question, right? Is that how you use it? So like as a developer, a lot of times if you want it to write code for you, the first thing you have to do is drop in a whole bunch of extra code before you ask it a question, and then it'll come back. That's really what we're talking about. But we don't necessarily want to go to ChatGPT to do all of this stuff. We want to have more control over, and do all of this in an environment where we're already creating enterprise level applications in a mature environment that has those capabilities, combined now with what you see on the screen, which is OpenShift AI. So OpenShift AI is it's like one box out of many boxes. So when you look at Red Hat OpenShift, I know you guys have come to this RHUG quite a few times, and we've talked about OpenShift. I'm trying to get better because there's so much in it, trying to reach a certain point where you can see all of the possibilities because of the level of maturity that has gone in the number of years that have gone into a platform like this. You can take any one of these boxes, and I see companies trying to kind of reinvent stuff in any one of these boxes, and it can take years. So, if you look at this as basically it's a flexible environment, but when you don't want to reinvent the wheel, there's going to be something there for you to take advantage of. But it also provides the flexibility for you to pretty much do whatever you want and run anything. And then just in one of those boxes, so like over here on the far right-hand side, you see like, so data-driven insights, like AI/ML. You can break that open, and it's this, like Red Hat OpenShift AI, or it's very modular. It does model serving, model development, monitoring. It allows you to do Jupyter notebooks, as well as take all of that and then put it into a comprehensive CI/CD pipeline, as well as marry that with the developer experience. And it brings it all together so that you don't just have to have data scientists that is doing this stuff anymore. It's completely accessible to any type of developer. And there's something in these boxes that's going to make your job and your life a lot easier. So that's what I'm doing. I want to show exactly what it is. I can't show all of the pieces, but I'm going to start with like the end goal and then move back. And then hopefully the rest of the stuff that I'm showing won't look so scary, but you'll see how we can bring all of that together with the thing that I'm going to start with up front. So there's stuff for the stuff that we've had for application development all the time. To make the stuff that's in AI and the models do something meaningful, you still have to have all of these other pieces. Red Hat basically has support for everything, app runtimes, API management. Yeah, I mean, you name it. There's serverless frameworks inside, and it just makes it so that no matter who you are, from the admin to the developer, your job is going to be easier. All right, so at the end of this, I'm going to show all of what OpenShift AI is, as well as like the first beginning, like what's the goal to get us to where we can actually use all of this stuff. But at the end, I have a pretty cool AI starter kit that I've worked on for a long time, and that I've open sourced, and it's a really good place if you actually wanted to get hands-on. I have a Git repository that has all the source code that's going to show you exactly how to do what I do at the end, which is, you'll see what it does, and I'll talk about this again later. But it's got the single sign-on. It's got the ability to have a front-end custom application, as well as a CMS headless backend, and then it talks to this Quarkus Java application with a number of assistants that can do things like natural language to SQL, as well as talk to data, talk to your notes. So this front-end custom application allows you to create goals and tasks. And then as you add notes, you're able to talk to that data with a vector database that comes back and then talks to that LLM, which is hosted on OpenShift as well. You can do all of that inside OpenShift. So let's actually just get right into the demo. So I'm going to bring up a couple of things here. So let's first start with the end goal. Like, to me, the end goal is this. So this isn't OpenShift AI yet, but to me, I would like to be able, as a developer, to come in here to my software catalog and say, let's create something. I want to create an AI application with all the corporate standards built in for the pipeline so that I can do self-service. So when I build my first application, I don't just build a repository for my source code. I also build all of the things that make it so that my security procedures are being met, my pipelines are there, everything that's required to deploy this from dev all the way to production is already there. And we can do that with this type of catalog. So it's like the glue that ties everything together. So if we were to come in here and select, this securing the Quarkus software supply chain, we can answer a couple of questions. I'm just going to put two, next. I'm just going to choose a repository, review, and create. So to me, I'm just showing this because this is the end goal, where you actually have people developers that can take advantage of all the power that's in a platform like OpenShift. You have to have all of these pieces that come together in a way that doesn't look like chaos. And so that would be this view. So after it's built, we have an environment where we can come in and we can click on this link, which will bring up a cloud-based IDE that has the authentication baked in. It has all the packages baked in for the type of software that we're building with that particular catalog item. We also have access to the CI/CD pipeline, whether it's Jenkins or, in this case, we've got another one. So I'm going to go back to another item that I had already built. So my Quarkus app. So these tabs can be replaced with different types of CI/CD tooling. It could be GitHub Actions, it could be Jenkins, it could be Tekton. In this case, it's Tekton with things like being able to build the software bill of materials. And it allows me as a developer to come in and see at the hub just, hey, what are the CVEs that went into my software at a glance? So we have this thing called Advanced Cluster Security that's scanning and applying policies. So I can see all of this, but I don't have to go into the OpenShift console. So now that I showed that, I'm going to go into the OpenShift console. And this is where I wanted to show that, because you can take what I'm about to show and bring it into a much cleaner package so that it's accessible to anybody. So I'm going to bring up the first thing. I've got to relog in to my cluster. So I actually have a cluster sitting in my basement. It's got a bunch of machines. It's got 8 GPUs in it. So that's one of the nice things about this is you don't have to be an expert in as an operations person or even in machines. It's very easy to get OpenShift installed in the cloud, on-prem, you name it. You can pretty much you can get an environment like this stood up, so you can really do a lot of cool stuff. So I'm gonna log in. All right, and I'm gonna zoom in here. So this is my OpenShift environment. And how many people have come or at least heard about OpenShift? So I'm not just, okay, good, all right. So when we come in here, the first thing I wanna show is, right, we've got the operator hub. So there's a lot of things in here that we could showcase, but we're talking about OpenShift AI today. And how you get it installed, we can literally just come in here and say OpenShift AI, click it, and you've got a full lifecycle operator. You just basically click a button and it's installed. So what does that mean? Then it introduces, so operators introduce these native things to Kubernetes. One of the native things that it introduces is a data science type of CRD, so a custom resource definition. And I can come into my administration view, go down here. It's hard to view. Go to custom resource definitions, and I can find my data science. Or actually, a better way to do it would be to come in, go to installed operators, and I'll look at my OpenShift AI operator, and I'll go to my all instances. So it's literally, I just create a new instance of this data science cluster, and I'll look at its YAML, and it's got so as I mentioned, it's modular. So there's a bunch of different parts. Model serving, it's got the ability to spin up Jupyter notebooks, data science pipelines, you name it. And all you have to do is change these various states from removed to managed. So all of my stuff is managed right now, but that's all it is. Basically, click save. Declaratively, there's an operator that's looking at the state of what this YAML is, and it goes in and just deploys whatever you need. So it'll deploy a whole bunch of stuff. Now, to get the ability to handle Jupyter notebooks, it's literally just another operator. So there's operators for AMD cards. There's operators for the NVIDIA. So you basically go into the operator hub and then just find the NVIDIA GPU operator. And then you basically hit install. And then there will be components that get spun up that go and look for all of the GPUs that are in your cluster. So I'm just making sure that I'm checking off what I'm showing. So OpenShift. So now, once I've clicked on that data science cluster, and then that gets installed, OpenShift kind of modifies itself. And then what becomes available is OpenShift AI. And you'll see that up in the, rather than up, sometimes the operators will update the left-hand side, but in this case, you'll see this link to Red Hat OpenShift AI. And then you'll have another view. So this is OpenShift AI. And you've got a number of different data science projects. And those data science projects have things like workbenches and pipelines and models. You can see your models. So in this particular instance, I'm going to go to all projects. So I have a model being hosted with VLLM. And so let me show here. So in settings, you've got a number of different serving runtimes. And there's single model serving as well as multi-model serving. And when you're doing AI, there's a lot of different models that do different things. I have a model in here that is good at generating SQL. It has done some extra training has been done so that it can generate SQL from natural language. But there might be another model that's good at creating, so what Keith was talking about, GraphRag, being able to create the actual graph structure in like a Neo4j database or the DataStax, then you can have a model that was trained to do that. So if you had multiple models that you needed served, it's helpful to use something like a model mesh rather than having to deploy each one of those individually and them all having their own individual serving engines. so you can choose from OpenVINO, KaiKit. So this VLLM, I don't know if you heard, we acquired Neural Magic, which were one of the main contributors to VLLM. So all of those people are now Red Hatters. And what that is the ability to take commodity hardware. I've got in this cluster, I'll show you, I've got 2 4090s and 6 3090s. And VLLM can take those and get as much bang for the buck out of them as possible. It's basically taking commodity hardware, allowing you to serve a model, do inference in a very performant way, and you don't have to spend a bunch of time tweaking it. Another thing that VLLM does, which is nice, like if you were to use KaiKit or some of these others, when you go to Hugging Face, for example, and do a clone on their particular, if you pull down one of the models, it's basically just a repository. It's a Git repository, but sometimes to get it to work, to do like model serving, you have to convert it into another type. So there's a bunch of files in there called safe tensors. This VLLM, you'll just pull it down, drop it into an S3 bucket, and it's up and running. So it saves a lot of time and effort trying to at least just get your model to a point where you can use it. So once you drop it into that S3 bucket, point this thing at it, and there's also a model registry that's in tech preview. So rather than having to do an S3 bucket in Amazon or run MinIO on this, like I also can run MinIO and have S3 compatible storage where it gets served from. But basically it pulls that, and then this gets up and running, and then I have endpoints that I can use to talk to it. So this is an endpoint that I put into my application that we'll be using a little bit later on. So I brought that up, showed that. So let's go back to our data science projects. So I've got my AI hackathon starter kit here. And one of the things too that's helpful in an environment like this that I kind of skipped, but I do want to take some time to show. So when we introduce that operator for OpenShift AI, it introduces a lot of different custom resource types. One of those custom resource types is inference. So rather than, so we've got this inference service, and I've got my instances, and it's that Llama 3 SQL Coder 8B. I could come in here and just say models, deploy a model, and then walk through the user interface. It doesn't give me as much flexibility as just doing it in a declarative manner. So what I like to do here is create, an instance through YAML. So this YAML is stored in a Git repository. So again, going back to Developer Hub, you can have Developer Hub have basically that catalog item that generates not only this like source code template for the basic building blocks the developer would work on, but it will also deploy these components that are extracted, or you'd have this skeletonalized for what type of model that you wanted to deploy as well. So in this case, why it's better to do it with YAML is that I needed to do this tensor parallel size equal to 2. So the only one of my machines has 2 4090s, and an 8 billion parameter model requires more than 24 gigabytes of video RAM. Because when I just try to deploy it on one machine that has like a 3090 with 24 or one 4090, then it basically blows up, says it doesn't have enough, and then I have to like try to tweak it and change the context window. So what's nice here is I can just say, hey, you know what? You need to have a tensor parallel size of 2 and NVIDIA GPU operator of 2, and it will go out and just look at all the nodes that are available to it, and it just finds the right node that meets its criteria, and then it'll spin up. So that's what it's done in this case. All right, so I wanted to show in here, so this AI Hackathon Starter Kit, which is just a namespace inside, it's a project inside OpenShift. I have deployed 2 Jupyter notebooks. One Jupyter notebook has this Codeflare distributed training. So I'm gonna pop that open. And so I showed you the model serving and the inference. So when I say inference, it's just a fancy word for you're asking a model a question. You're just using it as is. But let's say you wanted to do some heavy duty training, that you actually had to modify it and do some training, but you didn't have $1 billion to spend on an H1, a machine that has a whole bunch of H100s in it. You only have access to a bunch of 3090s and 4090s, like me. Then I can come in here. Let me see. Demo note. Actually, I want to bring up my I want to bring up my other Jupyter notebook. Yeah, it's the same notebook. It's just I've got to find the right place I'm at. So it's in the basic here. One of the other things that comes out of the box with OpenShift AI is it's basically CodeFlare and Ray IO. Ray IO gives you the ability to use things like deep speed, or it looks at your hardware. You can create this Ray cluster, and the Ray cluster looks like this. So I've got a little bit of code in there, and I don't have to install a bunch of packages. All I have to do is just follow the documentation. I put in, so in here, if we're looking at this, so what this code does here in this Jupyter notebook, so this is what a data scientist or anybody that wants to play around with Python and work with models without turning it first into an application would use. So in here, I just go, I didn't assign, so one of the things that I didn't show you here, so when we come in here and create a new workbench, I can select an image, I can say that what size I want it to be, what accelerator, how many GPUs, but I don't want to actually attach, in this case, a GPU to the Jupyter notebook, because I'm creating something that can do distributed training. Like it can look at all of the different nodes, physical nodes in the cluster. So in OpenShift, you've got a bunch of worker nodes, they're separate machines, and I've got video cards on individual machines. And how, I have a limitation. I want to use these bigger models and I want to do training, but I have a limitation on how many video cards I can put into my individual machine. Well, this is a way to get around that. So I can come up here, start my Ray cluster, and in this case, I just wanted to use 4 of them, but you can see over here, I'm going to zoom in and go over to the right. So there's GRAM, but then there's also, maybe I got to get smaller again because it doesn't here. So over on the right-hand side, we've got the GRAM, which is the video RAM, 24 gigs. So I've got 4 machines that each have 24 gigs of RAM, and that's enough to train the model in this cluster or in this Jupyter notebook. So if I were to just run this, so I'm going to kick this off, and hopefully at some point I'll remember to come back to it, and then look, and then you can see as it pegs all of the different video cards that it has access to. And again, these video cards are running on individual, on separate physical machines. All right, so and then if I wanted to, I can come over and take a look at my observability, my dashboards here, and I have enabled the NVIDIA. So if I look at NVIDIA DCGM, I can see that I've got 8 GPUs in my cluster, and the average temperature is 35 degrees Celsius. And then whenever I run this little training stuff, this was a little bit earlier, or maybe this is now. It might be kicking it off now. Oops. Get back to the dashboard. NVIDIA. So this is a way to see what's going on with that physical hardware in your cluster. And that's just, you don't have to build these dashboards out. So OpenShift has Prometheus built in as well as Grafana, and you can have you can get the external Grafana dashboards, but a lot of those dashboards are already built in, and then you get it directly into this window here. So we'll watch. Let's see if any of these yet have started pegging. So you'll see eventually this percentage. So here, you can see that we're starting to use the GPU as we're training, and it'll show you the percentage and how much GRAM is being used on each one of those. And that's a way to, if you needed to get to the point where you're actually doing real, like we've got our own data, we want to have our model understand that, not just give it extra context and use RAG. I want to do fine tuning. You can do that with some pretty powerful software here as well. I think this is unique because Kubernetes is uniquely positioned to take advantage of scale, right? We've been people have been building over-engineered applications for a long time that didn't necessarily need the scale of Kubernetes. Well, pretty much day one, if you're going to do fine tuning, you need scale. And the scale of Kubernetes, being able to not have to be an expert in my hardware to figure out how to make this happen so I can do things like fine tuning that was only accessible to data scientists in the past, is super powerful. All right. So that, here, let me see, back in the notebook. So I mentioned one of the things that I mentioned. So I'll go back and look at our custom resource definitions that are introduced. And to try to, so I've got Jupyter notebooks that can claim GPUs. I've got the Ray cluster that can claim GPUs. I've got the inference engine that can claim GPUs. How do you keep track of all of that and make it so that you don't start running out of GPUs and people, using them that shouldn't be using them? So there's a queue. So if we look at the cluster queue and local queue, so if you define a cluster queue and look at the instances, you can make this whatever you want. But I basically, since it's just me on this cluster, I basically said, hey, I can go ahead and get 10 GPUs. I don't, I only have 8 in there, but you could make this 1. And then you can assign to a local queue. So if I go back and look at my queue, custom resource definitions, and look at local queue and instances, you can assign to particular namespaces a cluster queue, and then maybe one namespace. And you can even do this like MIG partitioning, so that if you have a video card that supports it, you don't have to even assign a full video card to a particular namespace. You could assign a portion of that video card to a particular namespace using this CRD. All right, now putting it all together, let's say you trained your model, you started hosting your model, and you actually want to use this in a real application. That's where OpenShift really shines. When we adopted Kubernetes like almost a decade ago, we were the first people to identify. So what we're good at is identifying what's going to win in the open source community and providing support and an actual working product around that. And so we did that for enterprise level applications. So OpenShift is not just get Kubernetes up and running and have it be easy to manage. It's also all of those other things that I very briefly mentioned around, API management and actual databases, as well as support for languages and Quarkus runtimes, the builder images that you don't have to become an expert, you don't have to know anything about Docker. All of that goes hand in hand with all this other stuff now that makes OpenShift AI accessible, or AI in general accessible to the average developer. So I want to go and take a look at one of my projects here. So if I go to Operator Hub, and this is where I want to maybe go back to this this slide here. Where was it? Did I kill that slide? I did. 1 second. So I'm going to show this application. So hopefully this will make a little more sense now. So I have an application that does this. So you have a user that comes in and goes to the custom application, and eventually it's going to, it stores a bunch of entities, things like goals, tasks, and notes. You sign in with single sign-on, and then you've got this assistant here that can store those embeddings, like those floating point numbers. It knows how to take what you put in and turn it into the floating point numbers that get stored into Redis Search. Redis Search has a vector database capability, but you can also use data stacks. So with OpenShift AI, then we're also going to have our model that you saw, the SQL coder, 8 billion parameters. So that's based on the Llama 3.1. So they took a SQL, basically a bunch of training data, and then trained it to be better at generating SQL. So I'm going to show a couple of things where one agent is going to do the NL2 SQL. The other one is just going to basically, I have a task, I want you to help me complete this task. And here's some notes that will help you complete this task. So I'm going to come in. Let's switch over to the developer view. And I've first started with adding things with just like source code, and it knows how to build it. So if I have a Git repository of source code, knows how to build that stuff. Then I extracted it out, and then I turn it into Helm charts, and then you could put that into a developer hub template, make it all just click button accessible. So that's where I kind of wanted to give that warning up front. Some of the stuff where I'm jumping around, it looks like a lot, looks like, geez, we can't give developers access to this. Why do you have a developer dropdown? It built up to that developer hub experience where they don't have to go into all of the stuff that I'm showing you. This is the admin view. Even the developer view is still the admin view. But if you had a really good developer, there's a lot of power here that, if they knew their way around, this is, because any application now has a lot of moving parts. So this application is no exception. So I've got that Quarkus backend, I've got a Strapi headless CMS, I've got a number of Postgres databases that are in the mix. I've got a Red Hat single sign-on. Try to develop that and have it all running in a meaningful way and not create a bad architecture that's just easier because you're on your local laptop. You need this type of environment to do the right thing, to make things that actually work pretty well. So I'm going to switch back over to the administrator view, and I'm going to go to my network routes. And I've got, so these are the routes that I can access to the various things, like the, so I've got my Keycloak admin, I've got the Redis front end, but here's a React front end. And it's going to ask me for my credentials. So I've got that Keycloak. So Red Hat build of Keycloak is a supported version. If you've heard of Keycloak, rather than having to pay by user, you get all of the same high-end OpenID Connect capabilities for applications that use single, OpenID Connect in an open source way. So I'm just going to log in here with Peterson.dean. Okay. All right. So you can, it's kind of like it started out as like a task. Help me with my tasks on a daily basis. And I could add tabs. So depending on the types of things that I add, so I've got a task here, or I've got a tab here for NL2 SQL. But up on the right-hand side, I can create tasks. One of the tasks I'm going to build or create, I'm just going to put it under health so I don't lose it. Health. I'm going to say Tommy's blood pressure. So I've been talking to a lot of different healthcare companies. And one of the things that we've been working on, and this isn't the solution, I have a different solution dedicated specifically to prior authorization, but this is just a little taste of what you can potentially do. So let's say we want to know a little bit about Tommy's blood pressure. And the question that I'm going to ask is, does Tommy have hypertension? And I'll make this bigger. Does Tommy have hypertension? And if so, what level of hypertension? Okay. So I'm going to create that task. And I'm just going to submit it right now without any context. So if I hit submit, it'll come back and say, sorry, couldn't find an answer. Well, let's say we go and add a note now, and we say, what are the clinical practice guidelines for that type of thing? And of course, my notes, where is it? Notepad. Somehow Notepad closed down. Here we go. Open. So I'm going to put in some clinical practice guidelines. Copy. Bring that over. And the title will be Clinical Practice Guidelines for hypertension and blood pressure. Okay. So I'm going to hit, and it auto saves. So you see all changes saved. I'm going to hit previous. And I'm going to add one more note. The note will be Tommy's health history. And I'll just drop in some information. He's 14 years old, and his last 4 visits were a little bit over. So if we go ahead and hit previous now, and then if we hit submit, hopefully we'll get a little bit more information. So based on the information provided, Tommy's blood pressure is 133 according to the clinical practice guidelines for hypertension and blood pressure. Tommy's blood pressure falls into the category of hypertension stage 1. So the model wasn't trained on that. I gave it extra context through the notes. The notes were stored in Strapi as an entity, but also stored in, so if I come back here and look at my Redis Insight, what I'm doing is I'm storing those notes as an embedding, which is just a bunch of gobbledygook, but it's floating point numbers. And that just makes it easier for when I put this in. So this stuff here in the chat window, this gets turned into an embedding, those floating point numbers, and they get compared, and it says, oh, the coordinates of this thing that you asked is really close to the coordinates of this other these other chunks of data that were stored as vectors, returns it back, and that's where you can see, so I've got these two notes, but I have the references. So this is what it used. It found these three chunks from the vector database. And then that's how it answered the question. So one of the interesting things that this can also do, if I were to switch now and look at, for example, let's see, I have one on, yeah, give me the films. So give me the films that I've, like similar, he had a DVD database or a film database. So I've just wrote some code that can also do and natural language to SQL. So under the covers, rather than just go to the vector database, get some extra context, and answer the question, what I want it to do is actually go and execute some SQL against a database that's also running in OpenShift. And so how it's triggering this is up here in my settings. So I've got a data source called example NL2SQL. So I can turn this on and off. So if this is triggered, then I'm going to come in, and now I can just literally just hit refresh on this guy. So give me the films that Gene Willis was in, and hopefully it generates the right SQL. So let's change it now. Let's say, so I've got a connection. So one of the things that you can do is like OC, and I can actually make it look like a database is local. So I've got this PG admin. So let's find another actress. So if we were to look at, or actor, if we were to look at find, view data, all rows. So let's look at Ed Chase. These aren't real actors, unfortunately. So let's just change this then to give me the field films that Ed Chase was in. Ed Chase. And I've got to update the actual. Okay, and I'm almost done. Ed Chase. All right, and then I'm going to hit submit. So hopefully it thinks for a little bit, and then it'll start writing out. So different things at this point. And I can take a look at what SQL it generated by looking at, so let's go to my workloads, pods that we're running. So the pod that's actually doing that is the vector ask. So let me filter this by vector. All right, so this is the one that's running, logs. So in here we should see the SQL that was generated. So what I do is I have a prompt in my code. So in the code, the first prompt was, you're a helpful assistant that helps me complete my tasks. If you have this database selected, the prompt becomes, you generate SQL and do it in this specific format. So where you hear of agentic routing and assistance, so the next step would be to add that type of capability, right? But I've kind of made that manual assistant. So like assistant is, well, you're a prompt that does specific things. Agentic routing, when you hear it, it's just a fancy word for, it's a little bit more automated for which prompt gets executed. And in this case, because of that SQL database being selected, then it knew to use the prompt that told it very specifically, generate this select statement. And that's the select that was able to generate based on the natural language that I gave it. And all of this code, again, like for all the way from spinning up, so if you were to spin this up with inside Amazon, so there's something called ROSA. It's very easy to just go and create an like a ROSA cluster, and I have automation. So that'll be out there in this. I'll share the public Git repository, all the way from spinning up that cluster with the GPUs you need, to just also creating all of these things in that cluster. And this is hours and hours and hours of work that you could build off of to actually create something that's pretty useful. And I mean, there's all kinds of use cases you could use this for. All right, that's what I had for today. Thanks. Any questions? Go ahead.
OpenShift AI add-on to the overall OpenShift?
It is. Yep. Yep.
Is that per? Is it per GPU? Or
yeah, there were some changes this year. So coming into 2025, I mean, OpenShift AI is an add-on, but you also you mostly pay for the GPUs that are in the cluster. So that it would be priced based on that. Whereas so it used to be OpenShift.
Or on the US side.
Right.
Yeah.
Yeah.
Yep.
Any other question over there?
Yeah. Yeah, this is running in my basement. So I've got 10 physical machines that each, so I've got 6 machines that have a 24 gigabyte GPU, and I've got one water-cooled dual 4090 machine. So one of the nice things about OpenShift, whether it's in the cloud, like the experience is the same, but even on bare metal, and I'm not like, he's the hardware expert, so I come to him for advice. Like you don't have to be a hardware expert. I've got all kinds of mismatched stuff, and I'm able to get OpenShift up and running. It just it just knows how to use it all. Oh, you can get you're able to even
do it all in one.
you can, yeah. I mean, what I showed today to get the kind of responses that I wanted to generate SQL, I had to use at least an 8 billion parameter model. And so that would require one node with at least like 32 to 48 gigabytes of video RAM. But the requirements on the actual machine in terms of CPU and memory, that you could have one single node OpenShift with a video card in there. And if you just wanted to run a small model, that would be enough.
Super slow.
Yeah, it's slow. So one of the things that VLM used to, so Neural Magic, we acquired them, used to focus on is CPU, like being able to host a model and ask it questions on just CPU and regular RAM. That I mean, they switched gears to just make it so that you didn't have to have as much GPU, because there's not really any comparison between how many tensor cores you can fit into a GPU versus how many CPU threads that you've got on a particular CPU. So that's what makes it work, is you have all of these different parameters that have to get stored, and especially if you're doing things like fine tuning, if you have like hundreds or thousands of tensor cores, then you have a lot more, like the performance is exponentially better. It's unfortunate at this point until we hit a breakthrough. But you can still definitely, like some of the like if you're not doing generative AI, if you're just doing predictive AI like we've been doing in the past, and it has one job to do, is this a picture of a cat, or is, yes or no, or like it's a definitive outcome, where you classify something or you try to predict something and not generate something, then you don't need this level, you don't need that much hardware.
Cool.
All right.
It's a lot of work.
Yeah.
Yeah, it looks, you make it look very, this is very easy, but there's a lot of stuff you did in the back.
It could be a lot harder.
Yeah.
If you weren't, I mean, it's a lot harder if you have to be an expert in databases and how to spin all of this stuff and hardware, but I think this is doable for the average developer now.
Cool.
Yeah.
Any other questions?